is an introduction to exercise 2K on applications of simultaneous equations on page 133 of our textbook. So, with this stuff, what we're doing is just applying our understanding what we already know. We already know how to form linear equations based on words. We already know how to solve simultaneous equations. Let's just put two and two together, not literally, and then solve worded problems. In this section, I'm not going to get you to write down everything. I'm going to highlight what is important, okay? Now, just like when it came to solving trigonometric questions, or when it came to solving linear equations, I had a series of steps that are important for you to be able to answer them properly. Same thing here, except I'm going to be highlighting what's important. We need to first define two variables. Can I get you guys to write that down as your first step? Define two variables. For example, it could be C is the cost of the total cost, and X is the number of potato chips in a bag, or whatever it is, right? So we're forming two different equations. We need two different variables. X and Y, A and B, X and C, whatever it is. Second step, we're going to write a pair of simultaneous equations. Sounds dumb, but you need your simultaneous equations. And that will almost always be given in, for example, one sentence as one equation, one sentence as another equation. It might be the total cost of potato chips and what else is at the canteen? Juice bottles is $3 or whatever it is. Or the number of potato chips in a bag is whatever it is. And then use it together in order to form your pair of simultaneous equations. Then, third step is to solve, which is the steps that we just looked at, the substitution and elimination. And then you can check solution. I'm going to leave that as optional for now. But substitute into original equations. And I say that because we need the X and the Y value. Or in some circumstances, whatever other polynomial it is. We need both values. You can't just use one. And then express in words. I was so close to saying express VPN. But yes, express in words.
Never express VPN.
So, define two variables, write out your pair of simultaneous equations, solve it, substitute, and express in words. Please stop tapping the table. Cheers.
Yes.
Any questions? Awesome. I'm going to leave that on the screen for you guys to copy down while I read through the example. We already got the one example. It's pretty straightforward once you're able to identify what information is provided. So the general two rules that I always follow when it comes to a maths question is what is the information that's given to you and what information do you need to give. That's it. Okay. So in this situation, we've got Andrew who buys 2 containers of ice cream and 3 bottles of maple syrup. It's a very weird combination. I don't think people eat maple syrup and ice cream together, right? Okay. For a total of $22. What information do we have already?
3 ice cream.
Good. 3 ice cream and 2 bottles of maple syrup. I'm going to first define my 2 variables. So I'm going to say, let's say I equals costs of ice cream. And I know it's cost. I'm not looking for the number because it already told me the number, didn't it? And later, if I'm reading ahead, it says how much does it cost. So I'm going to say I is the cost of ice cream. I'm also going to say M equals cost of maple syrup. If you wanted to be super pedantic, you could write M is the cost of 1 bottle of maple syrup in dollars. But I think this is fine for now. So if I is the cost of I is the cost of ice cream, M is the cost of maple syrup. The first sentence already gives us an equation. It says that 2 containers, so I'm going to write of 2I, because that's 2 ice creams, and 3 bottles of maple syrup plus 3M is a total of $22. So that's our first equation already. Second sentence. At the same shop, Bettina, which is a name I've never heard in my life, bought 1 container of the same ice cream and 2 bottles of the same maple syrup for $13. We're going to assume there was no inflation between the 2 times. That's 1 ice cream and 2 bottles of maple syrup, which gives a total of 13. You can see how it's separated. The first sentence gave us one equation, the second sentence gave us another equation. It's not always going to be like that, but predominantly it's mostly in that format. How much does each container of ice cream and each bottle of maple syrup cost? When it's asking that question, how much does it cost? What do we need to do mathematically? What are we ideally looking to do? Well, it says, how much does it cost? So we're just solving for I and M, aren't we? That's all we're looking for. So we've got our two equations here. If you would like, you're more than welcome to use x and y as long as you define it. You have to say, let this be this and let this be this. You cannot, and I want to be very clear about this because I'm being very pedantic in Year 9 Maths Advanced, you cannot just randomly say m equals to 3 and I equals to 6. Because the question never told you m is the cost of maple syrup. For all I know, m could be the cost of McDonald's chips, right? So you have to define. Okay, so we've done that. Then we just treat it as we would a normal simultaneous equation. Which do you guys prefer right now? Substitution or elimination in this case? Yeah, we could do substitution. Remember, my personal rule, you don't have to follow it, but my personal rule is substitution where you can, elimination where you can't. I'm going to look at the second equation. I'm going to say, alright, if I rewrite it, that's I plus 2m equals to 13. Why don't I just minus 2m both sides, and we get I equals 13 minus 2m. Any questions up the back? Okay. From there, let's do substitution. I'm going to write, and I could write sub-equation 2 include equation 1, but I'm just going to substitute it straight up. So that's 2, and instead of writing I, I'm going to write 13 minus 2m. That's not an m. There we go. Plus 3m equals to 22. Expanding that out, that's 26 minus 4m plus 3m equals to 22. Simplifying that, 26 minus m equals to 22, minus 26 on both sides, negative m equals to negative 4. Am I going too quickly at all?
How did you get the m by itself?
So it's negative 4m plus 3m. So it's negative 4 plus 3, which is just negative 1. So I should write that out. You could, but you don't have to. And then m equals to 4. Have I jumped too many steps for you guys? Are we okay with that? Thank you to the 2 people that nodded. Alright, am I done? Are we happy with that? Maple syrup costs $4. Ice cream, thank you very much. Which equation might we use for ice cream? We could use this one, but I actually have a different idea. Why don't we just use this one here? I mean, it's already got I equals to blah 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 because of earlier. So let's use that one. Because remember, they're all the same. It's a simultaneous equation. So theoretically, if we've done it correctly, we should be able to substitute whatever value it is into either equation as long as it's the same as the original ones. So I'm going to substitute that there and write I equals to 13 minus 2 times 4, which gives us 5. So am I done? What was the last step? Thank you very much. Write it in words. So, 1 container of ice cream costs 5 and maple syrup costs 4. Why do I not like this? Besides the fact that I spelled maple syrup wrong. Thank you. Units as well, especially when it hasn't specified dollars. So we have to write $5 and $4 here. Any questions? Okay, this is exercise 2K. I'm going to ask you guys to get started on that as soon as you finish writing down these notes.